Hi, my name is Christian Josue Muñoz Ramos, and we are going to talk about a study related to learning colligative properties. But first, we are going to talk about what colligative properties are to better understand the study. First, what are colligative properties? Many of the properties of true solutions follow from the small size of the dispersed particles in general substance with a molecular weight of less than 104 daltons. For true solutions, some of these properties are a function of the nature of the solid, color, flavor, density, viscosity, electrical conductivity, etc. Other properties depend on the solvent, although they can be modified by the solid: surface tension, refractivity index, viscosity, etc. However, there are other more universal properties that depend only on the concentration of the solid and not on the natural of its molecules. These are the so-called colligative properties. Colligative properties have nothing to do with size or any other properties of solids. They are a function only of the number of particles and are the result of the same phenomenon: the effect of solid particles on the vapor pressure of the solvent. Some characteristics of colligative properties. The term colligative comes from the Latin word colligatus, which means united, and refers to the union or relationship between the properties of a solvent and the solid concentration in a solution. The German chemist Wilhelm Oswald was the first to introduce the concept of colligative properties. In the year of 1891, this denomination arose in his work on the properties of solids, among which he included colligative properties depend only the concentration and temperature of the solid and not on the type of solid particles. Constitutive properties are those that depend on the molecular structure of solid particles in a solution. Additive properties, which are the sum of all the properties of the particles and depend on the molecular formula of the solid, for example, the mass. Colligative properties are not related to size or any other properties of solids, but only to the number of solid particles. These properties are the result of the effect of the solid particles under the pressure of the solvent vapor. How do colligative properties work? The operation of colligative properties is evident when a solute is added to a solvent to form a solution. There, the dissolved particle displays a part of the solvent in the liquid state, decreasing the concentration of solvent per unit volume. In a diluted solution, it does not matter what particles are treated, but there may be, for example, completely dissolving calcium chloride are treated, but there may be, for example, completely dissolving calcium chloride. Products three particles, one calcium ion and two chloride ions. On the other hand, if we dissolve table salt or sodium chloride, we will obtain two particles of sodium than table salt. Therefore, calcium chloride is a more effectively the enzyme agent at lower temperatures than common salt. Although colligative properties are generally considered for non-volatile solutes, the effect also applies to volatile solutes such as salt. If we add a pinch of salt to a cup of water, the water will freeze at a lower temperature than normal boil at a higher temperatures, have a lower vapor pressure and change is osmotic pressure. Another simple example is adding alcohol, a volatile liquid, to water. This lowers the freezing point that pure alcohol or water normally has, which is why alcoholic beverages do not usually freeze in domestic refrigerator. There are several colligative properties such as freezing point. In the freezing point, the solute hinders crystallization in solvent such as antifreeze in cars by lowering its freezing. Boiling point, by adding molecules or ions to a pure solvent, the temperature at which it boils is higher. For example, pure water at atmospheric pressure boils at 100 Celsius. But if something dissolves in the boiling point, rise a few degrees Celsius, osmotic pressure. The osmotic pressure is the tendency of the solvents to move from areas of lower concentration to areas of higher solute concentrations. The effect can be thought of as a tendency for solvents to dilute. It is the spontaneous passage of solvent from a more diluted solution, less concentrated, to a less diluted solution more concentrated. When they are separated by a semi-permeable membrane, the osmotic pressure, okay, the osmotic pressure is P is indefinite as the pressure required to prevent the passage of solvent through a semi-permeable membrane. The vapor pressure is non-volatile liquids exhibit interaction between solute and solvent. Thus, their vapor pressure is small, while volatile liquids have weaker molecular interactions, thus increasing vapor pressure. If the added solute is non-volatile, a drop in vapor pressure will occur since this reduces the ability of the solvent to pass from the liquid phase to the vapor phase. The degree to which a non-volatile solute lowers its vapor pressure is proportional to its concentration. Non-volatile liquids exhibit interactions between solutes non-volatile liquids exhibit interactions between solute and solvent. Thus, their vapor pressure is small, while volatile liquids have weaker molecular interactions, thus increasing vapor pressure. If the added solute is non-volatile, a drop in vapor pressure will occur, and since this reduces the ability of the solvent to pass from the liquid phase to the vapor phase, the degree to which non-volatile solutes lower its vapor pressure is proportional to its concentration. Okay, what is the article about? I read about an article from the colligative properties enfocated to students. Okay, what is the article about? The article tells us about how to teach colligative properties through software and how it facilitates their understanding. How this was carried out through the study of different groups. The organizers separated the students in different groups from the study of chemistry students in a university degree. All this is carried out in the order to enhance the meaning learning of this topic in students to improve their academic performance. How was this study put? A group of first-year students of general chemistry class for the chemical engineering career from the 2100 2012, 2011 to 2015 years. The students of these years participated in the development of this research during the period 2011 to 2012. They only used the real laboratory space, and from the forum 2013 to 2015, the virtual laboratory colligative properties was taught, which was later evaluated in physicochemical subject of their year. The representative sample was 10 students per school year who were followed up. The virtual laboratory activity is applied to the content colligative properties that consist of the following objectives: determine the molar mass of the solid by cross copy. Compare the cross copy descent of solution, dissociable and non-dissociable solids. In this way, once they have entered the virtual laboratory, students must select the solvent to use for the demonstration, benzene and sulfur respectively, and configure the simulator according to the state objects could bad. Students must carry out the procedure indicated in the image. The calculus realized for the students, this is of the present in the image. This is a calculus realized. M is a molalidad, K constant cross copy, mass of the solids, mass of the solvents, and mass molar of the solid. And this is exercise realized in the simulator, in the virtual laboratory. Okay. The results obtained by this study, this is the presence in the table. We see major qualifications. Okay, and later the students with the data obtained must make the pertinent conclusion with the data obtained. This is present in this table. The data obtained in this experiment are interesting to me because they show us that the use of new technologies well implemented can show an improvement, as we can see in the following tables. This is of great importance, but for students like me, the university level and for students at lower levels, preparatory, secondary school, or different level of study. Science, for example, today with the pandemic, the use of different tools, such as those proposed in this study, would have been very useful for understanding these topics. To include, I would like to emphasize that this study showed that the use of different technologies really maximize knowledge, and they can be seen in this graph. Uh, and in this graph, we see the 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 knowledge of these students, in which we see that as teachers and students adapted more and more to these tools, the improvement was better. And okay, my name is Christian Josue Muñoz Ramos. This is a video from physico-chemical for the teach Eric Figueiras, and thanks for your attention and goodbye.